A short while back, I made a little video about how you take an old familiar airframe that you like and remove a less efficient motor and put in a more efficient motor and just set it up so you can use it again and enjoy it. That first video covered that. But the first video started, I said I was not going to make it public. I was just going to make it for a couple of friends. As it came to pass, I did make it public. Then we did the work, we did the test flight, we came back here to the shop and made a few observations, and I made the comment that I just need now to work with props to get it to work like I want it to, and I wasn't going to bother you folks with how I went about that. This video is what I said I wasn't going to bother you with. The idea is that maybe some people out there would like to know. And also, this is kind of an addendum to the first video because there's some other things that happened, and I can recap that right fast. We said it weighed 2.7 pounds. I wanted 150 watts per pound. This isn't arbitrary, it's not whimsical. These numbers are based on observation. We can find several electric powered trainers and they do perfectly well, maybe a World War I scale model, and we can weigh them and we can see what kind of work, watts, work, same thing, is going on. We find that 75 watts per pound would make a good trainer. If we found a reasonably good aerobatic model, and maybe a World War II scale model that zipped along pretty good, we might find that it had 100 watts per pound. For unlimited aerobatics, 150 watts per pound. That's where I got the 150 watts. So if I had 2.7 pounds, 150 watts per pound, I would have 405 watts total. Divide that by my voltage, 3 cells, 11 volts. That would give me 37 amps. Gives you an idea of what kind of electronic speed controller I need. I had a 40 amp. That would work. The motor is good for 50 amps, so I ordered a 50 amp one just in case. Well, in the first video, we saw me adding 6.5 ounces of lead, a motor, a battery, big pieces of wood that those things are mounted to, and I didn't weigh it when we got through. I should have. It weighs not 2.7 pounds, it weighs 3.2 pounds. I had a total of 315 watts because we measured it. That tells I only had 98 watts per pound. No wonder it didn't go up like I expected. I thought I was going to have a total of 400 watts per total, and I only had 98 because of the weight I added. So, okay, now we know what it weighs. It weighs 3.2 pounds. I still would like to aim for 150 watts per pound. This means I need 480 watts. Divided by the 11 volts, 3 cells, I need a 44 amp electronic speed controller. I only had a 40 amp in it. However, I did get my 50 amp speed controller, so we can put this in. Now, using wattage to do this is really an intelligent thing to do because wattage is power. 750 watts is 1 horsepower. That is, if you had that amount of work being done on the output. We're only measuring what's going in. If our motors and propellers and gear trains, whatever, was 100% efficient, then what's going in is what's coming out. Well, brushed motors can only get up to about 80% efficient. Our brushless motors can get up to about 90%. That means it's only losing 10%. That isn't bad. But anyhow, the point is that wattage is power, wattage is horsepower. So now let me put this in that. I put a piece of tape on the nose on the motor to see what direction it's going to be going. You shouldn't work with ESCs with a prop on it. So let's turn the transmitter on, plug in the battery. The ESC just laying loose in here. Okay, up is up, down, left, right, that's right. So let's see which way this thing's going to turn. Okay. That's going the right direction. So this is wired properly. Now let's start seeing what kind of prop we can put on this thing. I've got the watt meter hooked up, and I'm going to pick a prop here. This is the prop that was on it. This is the Sonictronics. I like Sonictronic products. I've used it for years. It's good stuff. There's nice people making it. You can get hold of them on the phone, and they treat you good. But so here is the prop that was on it. We already know that just wasn't delivering, so we can put it aside. Next we have this one. I want long hubs, remember, because I want my spinner to fit right. They have a shorter hub, but here's the next one we're going to try. This was just, it's 11 3/8 by 7.5. That's just up a notch from where we were before. So let's see how this is going to do. Okay, I got the 11 3/8 by 7.5 prop on it. Turn receiver on, the transmitter on rather. Throttle back. Okay, watch yes. You're going to be looking right here and right there for wattage and current as I come up. Now I got a death grip on it. $381.34. 381.34. 34 amps, 381 watts. That's interesting. Okay, I have a 12 5/8 by 7 prop on it, and let's see what's going to happen now. Transmitter on, throttle back. Yes, I want to measure watts. Remember, we need to be looking at that current and that wattage. And I have a death grip on it. $438.40. Now I have a 13 7.5 prop on it, and I can already tell I'm not going to go any more than that. I got a 14 prop, but no, I'm already getting a good idea what I'm going to do here. So okay, watch current and watch wattage. Here we go. 43, 472.43. 472.43. I'm going to check that current again. That doesn't seem right to me. So we'll do it again. $460.43. Well, okay. It says 43. I guess it's 43. Now let's write this down and see what it says to us. Well, we've gone through and checked the plane out with 4 good old Sonictronic props of different diameters and pitches. I would have had more choices if I had not been needing the longer hub. Sonic Tronics, good people, good products. So let's see what all we found out. One thing I found out is that I'm through. I've got the information I needed. With the 10 3/8 diameter, 6.5 inch pitch, we had 315 watts at 27 amps. Went up to 11 3/8 by 7.5. We got 381 watts at 34 amps. We went up to 12 5/8 by 7. We got 438 amps at 40 amps. We're getting there. Then at the old reliable 13 7.5 that I've used more than any other prop, we got 472 watts, 43 amps. We wanted 480 watts and 44 amps. Well, that's close enough. The now becomes that little balancing act you always go through with electric powered aircraft. How long is the battery going to last? Well, I remember when the wet flyers were saying, I don't want to fly electric, they don't fly long enough. And I would ask, long enough for what? They never really had an answer. Well, in the case of using a 2.2 amp battery, that's good for about 27 amps a minute. And so this equates to basically a minute of climb time, because in about 15 seconds with this power here, the very first power we said that didn't go up like I wanted, I was getting about as high as I could comfortably see. I stopped competing because my eyesight got bad. So you can say 3 or 4 climbs on a battery charge. That doesn't sound like much, but when you're getting as high as you can comfortably fly, and now you're looking for thermals. That's why you're using motors to start with, is to get up and try to find thermals. This is a sailplane. That's its purpose. This is just a way to get it up there. A lot of guys will fly their sailplanes and leave their launching motor and their launching battery on the ground. Some of us don't have miles and miles of real estate to string a winch or a high start anymore. So we have to take our launching battery and our launching motor with us. There's lots of advantages of that. So we'll have plenty of climb on one battery and be able to spend a lot of time in the air looking for thermals. And that is the fun. That is why we're doing all of this. I learned a lot. I hope you did too.